Now see here Kirchhoff's laws. First law is here, that is called junction law. According to this law, the algebraic sum of currents meeting at a junction in a closed circuit is 0. That is, the sum of the current is 0. Suppose you have taken, this is the junction point, one current is coming from here, that is I1, another coming from here, that is I2, third one is coming from here, that is I3, and one is going like that, that is I4, and another is going here, that is I5. So, at the junction these three currents are coming towards the junction and the rest two are leaving the junction. So, we can write I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. So, we can write I1 plus I2 plus I3 is equal to I4 plus I5. So, according to this junction rule, the total current entering into the junction is equal to the total current leaving the junction. Now, see here second Kirchhoff's law, that is the loop rule or the voltage rule, or we can say loop law or the voltage law. It states that the algebraic sum of changes in potential around any closed path of electric circuit involving resistors and cells in the loop is 0. That means that is sum of the change in potential is equal to 0 in a closed circuit. So, let us understand this statement with the help of an example. Suppose we take circuit like this, there is a cell of EMF, this one, and another, and there is a resistance here R1. Another cell we can take here like this, EMF E2 here, and we can take another resistance R2 and we join like this. So, this is a closed circuit. This is A, B, C and D. So, suppose current is flowing from here, we take I. We can take any direction, answer if it is actually opposite, current result is coming actually opposite to that, then the answer will be coming negative. Otherwise, you can choose any direction of the current. So, the current is going like this. Suppose we take a closed loop A, B, C, D, A. First, we will traverse the path A to B, B to C, then C to D and D to A. When we are going from A to B in this path, so see here, this is a higher potential and this is at lower potential. We are going from higher to lower potential, so obviously potential difference will be negative. So, we can write its EMF is negative. Now, here the current is coming B to this side, it means opposite to our movement. Current always flows higher to lower potential, it means we are moving here lower to higher. So, we can write here plus IR1. Here again in the cell B to C, we are moving in the cell here higher to lower. So, we can write here negative potential EMF. Now, C to D, we are moving opposite to the current, that means lower to higher potential. So, lower to higher potential means potential difference will be positive. So, we can write here IR2, and when we are going D to A, there is no current, sorry, there is no component resistances or the cell. So, that is here, leave it and you are reaching to the point A. When you are reaching to the point A, this sum will be equal to 0. Now, we can solve for the value of I from here if you need to do. So, we can get it here I R1 plus R2 is equal to EMF of one cell plus EMF of the second, and we can write I is equal to EMF of the first cell divided by second, plus second divided by R1 plus R2. So, this is the current. So, see here, when we go from higher to lower potential, we take potential difference negative, and when we go from lower to higher, we take potential difference positive. Only this is the concept or this is the method we use to apply voltage rule or the loop rule.